Let's find inverses of functions. And because we've already started to understand compositions of functions, decompositions of functions, and so forth, we're going to look for the inverse of a function. And basically that means is we're going to take some function, do some stuff to it, and if we reverse that procedure, do we get back to where we started from? So to determine if these two functions are inverses of each other, I need to evaluate f of g of x, and likewise to see if that equals g of f of x, which all equals x. So let me use this by example to kind of get a sense of what's going on here. So let's look at f of x. So I take my function f, which is 3. Instead of putting in x, I put in g of x, which is an x minus 2, all over 3. Continue my function f of x plus a 2. So let's go ahead and reduce that down and see what that reduces down to. 3's cancel out. So I'm left with an x minus a 2 plus a 2. And that reduces down to x. Now let's look at the second function. So this was f g of x. Let's look at g f of x. So my g function is over there, x minus 2, but rather than an x, I'm putting in f of x, so that's a 3x plus a 2 minus a 2 all over a 3. And let's go ahead and reduce that down, see what that looks like. The parenthesis I can go ahead and eliminate. So 3x plus 2 minus a 2 gives me a 3x over a 3. 3's are a clever version of 1, so I can just write it as an x. So as you notice, when I take the composites of both these functions in both directions, they both reduce down to an x. And when that's the case, I can say that these original two functions are inverses of each other. And that's the test to find out if two functions are inverses. F of x equals 3x plus 2, and it has an inverse, which is x minus 2 over 3. And the way that I can designate that is I can write f of negative 1 of x. The inverse of x is x minus 2 all over 3. And sometimes determining or discovering the inverses of functions can be a powerful tool to help us solve some more complex problems.